Welcome back to Troubleshooting Pandas. We're in the second chapter about cutting through all the irrelevant data. In this video, we're going to talk about dropping useless data with indices. So here we are in the second chapter, so we're using the chapter 2, Jupyter Notebook. The motivation for this chapter is that due to cheap storage, it is common that data is collected greedily, and your first step with Pandas is to cut down the data to a dataset that is appropriate for your use. In this chapter, we're going to require Pandas, which is here in in10 is imported as PD. And we're going to introduce you to a new scientific computing library called NumPy. And it is here imported as NP. So very much like Pandas, NumPy is also imported with a shorthand, and you're going to see this everywhere on GitHub and in other open source venues. So let's get right into it. Dropping useless data with indices. One of the most powerful things you can do with Pandas is to create a multi-index or hierarchical index object and use this to index your data frames. For example, in in8, we're creating a list that comprises of tuples, with the first one being one of 4 variations between bar, baz, foo, and kicks. And so, in the second level or the second item of the tuple in this list, levels, it can either take the form of 1 or 2 variables, which is 1 or 2. And so the combination between 4 variations in the first elements of the tuple and 2 variations in the last elements of the tuple, we get 8 combinations in the levels. With this sort of list, what we then do is call a function that is at the Pandas core, and we are using this function called multi-index.fromTuples, very self-explanatory. And so this fromTuples function gives us 2 parameters. The first parameter is what tuples we need to use to set up the index, which we're feeding in the list of tuples that we've defined, named levels. And the second parameter that we can optionally specify is the names parameter. So what does the names parameter do? The name parameters allows you to feed in a list of names, of which by position corresponds to the name of the level in your multi-index. In our case, we're feeding in a list of first and second as words in strings in a list into names. And so our first level in the multi-index is named first, and our second level in our multi-index is named second. Very simple, very easy to follow. And if we print out what is our index, we can see that it returns exactly what we expect. The first level has 4 variations, the second level has 2 variations, and the names for the first and second level is first and second respectively. Now, if we create a series, and creating a series entails using pandas.series, and we need to feed in some values, right? So a very simple way to do that is to use NumPy's random.renn function. And this function gives us 8 numbers that is random from a standard distribution. And we can feed these 8 numbers corresponding to the 8 tuples that we have created in levels and use the index that we created just now here to index this data. So after we call pd.series in 11, we can see that the out11 gives us a very neat multi-level data frame, which the first level has 4 variations and the second level has 2 variations, and the values are whatever random numbers that NumPy has generated here. So let's look at how we can index within axes with the multi-index, right? So how can we select subsets of the data when we have a multi-index? So here we have a data frame that is created by pd.dataframe, and we have an index that is ABC and a columns that comprises of 2 levels, which gives us the multi-level column index, And so if we print out data frame df, we can see that there are 24 random numbers that we've generated, and they're spread across a frame where the columns are multi-level and the rows are single level. To find the first subset, it's very easy. We can use the indexing that we're very familiar with from the dictionary world, and if we say data frame bar, it slices out the data frame to give us only the two columns that are related to bar. So these two guys. So this guy and that guy. And so here df bar gives us these first two columns, and bas and foo and so on and so forth does the same. We can also index by going from the top level to the second level and only selecting a particular column. And here what we have done is to use the loc function and feed in a tuple, which allows us to then take the series that belongs to bar and 2. And the reason why there's a T there is we needed to use the transpose of this data frame to enable our use of the location access function and feed in a tuple that corresponds to the first level and the second level of the index. Similarly, after we've selected this, so we can further subset these columns by first taking the series or the column that is corresponding to bar and then subsequently 2, and then we can give it a further index, which is A in our case, to get this particular number here. We can also use a range indexing function from Pandas where we basically select bas to foo. So here we can see that bas to foo comprises of these 4 columns. And so if we call this with a slicing operator instead of a tuple, then we'll get a range of all the 4 columns. And because we have used the transpose here, it's transposed and sort of flipped the matrix by 90 degrees. So here I'm simply showing what happens if we simply call df.t, which gives us a transpose of the Pandas data frame, and it basically rotates the data frame by 90 degrees, and you can see that the multi-level columns became the rows and the single level rows became the columns. The other cool thing we can do is here, if we look at in42, we do df.t.mean level equals 0, is we're taking the data from the first level and aggregating over the second level. And by aggregating, we apply a mean function to get the average over the sets. If again we aggregate over the first level, then instead of going forward, taking the big buckets and aggregating the small buckets, we take the small buckets and aggregate out the big buckets. So there are a lot of situations where you want to do this, and this is how you do it.